Is it possible for a gentle electrical stimulation to the head to assist doctors in operating surgical robots? Greetings and salutations to everyone. Today's video focuses on a groundbreaking discovery made by researchers from Johns Hopkins University. They have uncovered that by applying electric stimulation to a specific area of the brain known as the cerebellum, medical professionals can effectively transfer skills acquired in virtual reality to real-life surgical settings. In this study, participants were administered gentle electric currents to the back of their heads, resulting in improved dexterity when operating robotic surgery tools in both virtual reality and real-world scenarios. Remarkably, those who received the stimulation exhibited greater proficiency compared to those who did not. This research has the potential to revolutionize the field of surgery, enabling surgeons to acquire new skills in half the time. Moreover, it holds promise for other industries that rely on virtual reality training. Without further delay, let us delve into our discussion. According to a recent study, individuals who were exposed to gentle electric currents on the back of their heads demonstrated significantly greater ease in operating a robotic surgery tool in both virtual reality and real-life settings, in comparison to those who did not receive such stimuli. According to Jeremy D. Brown, a roboticist from Johns Hopkins University and the author of the study, the results provide an initial insight into the potential of stimulating the cerebellum to bridge the gap between virtual reality training and real-life surgical procedures. This transition is crucial in a field that heavily relies on digital simulation training. According to the John C. Malone Associate Professor of Mechanical Engineering Brown, previous research has demonstrated that there is a notable disparity between training in virtual reality and training in an actual environment. The ability to apply skills learned in a simulation to real-life situations can be challenging. While it is difficult to establish precise statistical accuracy, the study found that participants were able to more effortlessly transfer their skills from virtual reality to the real world when they had access to this form of stimulation. Today, you can find the work published in the scientific journal Nature Scientific Reports. Using the Da Vinci Research Kit, an open-source research robot, participants replicated the actions required for surgical procedures on abdominal organs. First, they practiced driving a surgical needle through 3 small holes in a virtual simulation. Then, they repeated the process in a real scenario. The researchers emphasized that these exercises closely imitated the movements necessary during surgical operations. During the experiment, electrodes or small pads were applied to the participants' scalps to administer a gentle electric current to their cerebellums. Half of the group received continuous electrical stimulation throughout the entire duration of the test, while the remaining participants only experienced a brief stimulation at the start and no further stimulation for the remainder of the tests. Individuals who were subjected to the consistent flow of electrical currents experienced a significant enhancement in their manual skill. It is worth noting that none of these individuals possessed any prior experience or training in the fields of surgery or robotics. According to Guido Caccianiga, a former Johns Hopkins roboticist who designed and conducted the experiments and is now at Max Planck Institute for Intelligent Systems, the participants who did not receive any form of stimulation faced difficulties in transferring the skills they acquired in virtual reality to the physical robot, particularly when it came to executing complex and rapid movements. On the other hand, the groups that underwent brain stimulation exhibited superior performance in these specific tasks. The researchers have highlighted the potential of non-invasive brain stimulation to enhance motor learning in rehabilitation therapy. They have taken their investigation a step further by exploring how stimulating the brain can assist surgeons in acquiring practical skills. Gabriela Cantarero, a former assistant professor of physical medicine and rehabilitation at Johns Hopkins and co-author of the study, emphasized the team's efforts to advance research in this area. Cantarero expressed his excitement over the fact that they were able to effectively influence behavior through their setup, enabling them to meticulously measure and analyze every minute detail of people's movements, variations, and mistakes. Enhanced vision allows surgeons to perform fine and precise tasks with the assistance of robotic surgery systems, which in turn help minimize hand tremors and enhance human skill. Clinicians benefit greatly from these systems. In addition to its impact on surgical education, this form of brain stimulation holds potential for enhancing skill acquisition in various other sectors that heavily rely on virtual reality training, such as the field of robotics. According to the researchers, the potential benefits of this stimulation extend beyond virtual reality and can potentially enhance general learning abilities as well. Imagine the possibility of demonstrating that through the application of brain stimulation, the acquisition of new skills can be accomplished in half the usual time. This significant reduction in training duration would have a profound impact on costs, as individuals could be trained more rapidly. The resulting resource savings could then be allocated towards training a greater number of surgeons or engineers, who will undoubtedly be working extensively with these technologies in the future. Among the list of authors are Ronan A. Mooney from Johns Hopkins University School of Medicine, as well as Pablo A. Selnick from the Shirley Ryan Ability Lab. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.